Let's look now at a few examples where you'll often see percent calculations. The first example is when calculating tolerances. On technical drawings and specifications, measurements are often given with a tolerance that recognizes that not every part will be exactly the same dimensions. The tolerance shows the allowed variation in those parts, and is communicated with the plus or minus sign. The tolerance values may be given in the same units as the measurement, which means we can simply add or subtract that value, but often they'll be given as a percent. Let's look at the first example. Here we have an electrical resistor rated at 500 ohms plus or minus 10%. This is sort of like saying the resistor is rated at 500 ohms, give or take 10%. So either 10% lower or 10% higher than that value. Here we want to find what is the highest value that the resistance could have in this range. What the tolerance is saying is we expect the resistor to be rated at 500 ohms. But our upper limit could be 500 ohms plus an additional 10% of that value, and our lower limit could be 500 ohms subtract 10% of that value. In this case, we're asked for the highest value, or the upper limit, so we want to take 500 ohms and add 10% to it. We can't do this addition right away because the units are different. Here we have ohms, and we're trying to add a percent. So our first step is actually to figure out what is 10% of 500 ohms. To do this calculation, we know we need to use our percent as a decimal, so 0.1, and 500 ohms is our base. We're trying to find the part that would be 10%. From the previous videos, we know that to find the part, it's the percent as a decimal times the base. So 0.1 times 500, the part or the increase that we'll add is 50 ohms. So to find the upper limit now, we can take our 500 ohms and add 50 ohms. So the upper limit is 550 ohms. So this is the highest value the resistance of this resistor could have. Pause the video for a moment and try the next question. Notice in the next question, we're given dimensions of a fitting, and we're told they're 1.370 plus or minus 0.15 inches. So the tolerance value is in the same units as the original dimension. So you can do the addition and subtraction right away to find the tolerance limits. In this case, find both the lower and the upper limits. Those will be two separate calculations. Once you've done that, try and figure out what is this tolerance limit, 0.015 inches, as a percent. Pause the video and then check your answer. Take a look and see how you did. To find the upper and lower limits, we're simply taking the dimension and, for the lower limit, subtracting the tolerance value for 1.355 inches. For the upper limit, we add that tolerance value, so the upper limit is 1.385 inches. To find the tolerance as a percent, remember that percent is the part divided by the base times 100. Here the part, or the portion, is the tolerance in inches, 0.015, and the base is the original dimension, 1.370. So the tolerance as a percent is 1.1%. Another place you'll see percent calculations is finding efficiency. We often talk about the efficiency of a machine or a process. The efficiency compares the output we get from a machine to the input we put in. So the output is our part and the input is our base. To get to a percent, we multiply by 100. We could use this to solve for either the efficiency as a percent, or we could rearrange it to find the output or input values. Remember, the output and input values must be in the same units before you calculate efficiency. In our first example, we have an electric motor supplied with 100 watts of energy, and it puts out 85 watts of mechanical power. So the input is 100 watts, and the output is 85 watts. Both of those are already in the same units, so we can go ahead and calculate the efficiency. Efficiency is the output, the part, over the input, the base, times 100%. So here, 85 watts out of 100 watts the efficiency of this motor is 85%. Notice you'll know if you've made a mistake if you get an efficiency value that's greater than 100%. If you do, likely you've mixed up the output and the input values. Pause the video and try the next question. Here you have a light bulb with a known efficiency of 10%. The bulb uses 100 joules of energy, and we want to know how many joules of light it produces. So you're looking for the output, knowing the input. Think about how to rearrange the equation, knowing the percent, to find that value. Rearranging this equation is just like rearranging the percent equation. The output is just like solving for the part. So to find the output, we take the efficiency, remembering that it needs to be as a decimal. We convert from the percent form, and we multiply by the input. When we do this, 0.1 times 100 joules, the units for the output will be the same as the units for the input, so we get 10 joules of energy as our output. Our final application example for percents will look at taxes and discounts. You often see percent values dealing with taxes and discounts, and these are likely calculations you've done before. We'll look at a couple of examples and recognize that there are multiple ways you could complete the steps to solve these. We often see discounts taken on amounts, and then we need to calculate tax as well. Remember that discounts are taken off the bill or the subtotal before the amount of tax is calculated. Looking at this example, if you get a contractor's discount of 20% off your bill at a hardware store, and we know the tax on the bill is 13%. The bill subtotal is $1,432.27, and we want to know what's the final total going to be after the discount is applied and the tax is added. A couple of ways to look at this problem, but we'll have to do at least a couple of things. We need to find the amount of the discount and then add the tax onto the new bill. So first we'll find the discount. We know that the percent for the discount is 20%, or as a decimal, 0.2. And the total bill is $1,432.27, so this would be our base. We're looking for the discount, or the part. So to find the discount, we'll need to take the percent as the decimal and multiply by the base. 0.2 multiplied by our bill amount gives us, to 2 decimal places for money, a discount amount of $286.45. So to figure out our bill amount, we need to take the original amount of the bill and subtract the discount. This means that the amount of the bill after the discount is $1,145.82. That's our new bill amount that will be taxed on. Maybe you think about this question in a different way. If you have, pause the video, try and think of another way to solve this to figure out what the new bill amount is after the discount, and then check and see how you did. You may have thought about the problem this way. Instead of looking at finding out what 20% off is, you could think about it as you're only paying 80% of the bill. So the part of the bill that you're paying is 80% as a decimal, 0.8, times the bill amount, or $1,145.82. Either way, we've found out how much we're going to be taxed on. Now we can apply the tax, 13%, to this new bill amount. Again, there are 2 ways to do this. We could figure out the tax amount by figuring out 13% of the bill and adding it on. Or we could look at taking 1.13, 113% of the bill, which will do the addition for us. This is often how you've likely calculated tax in the past. The total will be the percent as a decimal times our base bill amount. The percent, 1.13, is 113% written as a decimal. This gives us the total bill amount plus the 13% tax, and we multiply that by our new amount and find that our total bill that we pay is $1,294.78. Use the method you're most comfortable with and try and solve the question below. You're buying 12 breakers that cost $14.54 each. So first you need to calculate the subtotal of your bill. Then this time you're given a 10% discount and then adding 13% tax. Use all that information to figure out your final bill amount. Pause the video and then check your solution. After working through the steps to figure out a subtotal of $174.48, you can apply your discount and should have found that after the discount you're paying $157.03, and then finally, after adding the tax, your bill will be $177.44.